Hello again from Bob's Retro Electronic Workshop, sister channel to Bob's Barn Workshop. This goes out to all those Commodore fans that have, you know what this is. This is the original Commodore 1541 disk drive, which is the disk drive that has the original Mitsumi Neutronics floppy drive in it. When the heads go dead, this drive is useless. Even though every other mechanical part in it might still be perfect when it searches for files. You can tell, you search for a file, it runs, the motor moves, you hear the head slam, you get file not read error, you just get errors, you get nothing. You take an ohm meter, you measure their heads, and they're 15 k ohms. There's no repair for this. I am going to show you in the upcoming sequences how you can take a drive like this that's been dead forever and restore it to full function, full working capabilities with one used part that you can get for $50 with shipping or less, and very little mechanical modification to make this drive as good as new. So stick around and watch this, because this is a significant step for all you Commodore retro computer guys out there that have these on their shelves for years, or try to sell them on eBay or whatever. Stick around and see the solution. I'm sure you'll be happy.
I'll tell you a little story.
Hey fans, welcome back to Bob's Retro Electronic Workshop, sister channel to Bob's Barn Workshop. You want woodworking, you want hot rods, you want mini bikes, you want lawn equipment, you want some building, you want some different stuff, go to Bob's Barn Workshop. But there's just too much content in this channel I wanted to use. So what I have here is an old Apple disk drive that I bought for 29 bucks. And I saw Adrian of Adrian's Digital Basement experimenting with one of these, and it gave me a brilliant idea, which it's either infeasible and other people have tried it and never said anything about it. I don't know why nobody would think of it. But let me show you something. Did I not loosen those enough? Okay, we have dissected that part of it. Let's see what else we can get apart here. Are there screws back here? Is that just shoved in there? Yes, it is. I don't want to spill my damn coffee. Dang it. See anything holding that? Oh, yes I do. There's one screw in the back. There's two screws in the back. Okay. Don't forget to take the two screws in the back that are back here, which my damn thing won't reach because it's got a big knuckle on it. I thought I brought another screwdriver. Try not to go blind, guys. That would be my other hint in life. So loosen these two screws. Now I bought this untested Mac drive for 29 bucks. With shipping I think it was 42. Okay. Seems like a quality item. But what we're trying to get at is the goodies inside. So we're just going to keep taking screws out here.
I'll tell you a little story.
Now, this is what we're after. This is an Alps drive. And an Alps drive was used in some of the Commodore 1541 drives. Now the beauty, now if you have one of these old 1541s, this has the Mitsumi Neutronics drive in there with the heads that go open for no reason, making this drive pretty much worthless because it's impossible to change those heads unless you're magic. But everything else works fine. So what do? Commodore made two types of drives. They used the 1541 with the Neutronics drive, and they did the 1541 with the Alps drive. Now my experiment is going to be to hook up the Alps drive in the old 1541 and take out the Neutronics drive. And I think there's only one jumper in here you have to change. The motherboard between the two drives of manufacture were exactly the same. So there was no difference on the operating system or the stepper motors or nothing. What I need to do is I need to trace out all these wires one by one to the motor to get them to go to the proper pin headers here, and take these headers off each one of these as we go. Now that's the power LED. Take these off as we go and figure out what is what. So here we've got like the motors, and here we've got the just different things that turn on and off by the micro. And we're going to see if we can make this drive work. The only caveat is the latch mechanism. Now the latch mechanism does not hook onto anything in this plastic. So I could just put this drive in the hole for right now with no bezel. But I'm going to try to get the bezel reproduced with 3D printing. So there, I've revealed my secret desire here. We're going to measure the heads on this drive first to make sure that we've got a good head in there. Now they should be around between 15 to 30 ohms. It's my fingers that I'm measuring. Okay, there we go, 28 ohms. 18 ohms, 35 ohms. This has a good head. This drive mechanism should work with that just fine. My only concern is, are the stepper motors different that moved the heads? If they had different step rates, then they're going to be screwed up. So I guess I can just take all of these out. And actually I've got a drive over there with a Alps head and an Alps drive, so I can just copy the pinouts of the colors. Now unfortunately there's, you know, 2 browns, there's 2 oranges, there's 3 browns, there's a blue, purple. I've got to find out what goes to what. Okay, there's the stepper motor. This ain't going to be that hard to figure out. And this one over here is the stepper motor, which has got 6 pins on it. And they use brown, orange, yellow, 2 reds. I'm hoping the reds are common. That might just be power. So we've got to snip these tie wraps. I'm pretty excited about this actually, guys. This could be a pretty cool thing. You know what I'm going to have to do? I'm going to have to splice all those wires. So what I'm going to do is I'm going to save this connector here. I'm going to put this one right back in. And unfortunately I have to splice them all. I was hoping I could just pop them out. Oops, don't pick the pin. Okay, I got to get the helping hands out. You got to move because you're right in the way of what I'm doing. So this is a much better way to do it. Ideally, you should twist these together so that your butted wires behave. All right. Now, how do we heat shrink these? Well, one at a time. You put your thing over the joint and use the barrel. So that's where the heat is. Up in the barrel of the soldering iron. And we just one at a time convince these guys to melt together. All right. Step number 1, we'll just twist these guys all up like they were. So now I got to figure out what the rest is. All right, well, on this Alps drive over here, the original 1541 that still works has a brown and orange. No, maybe it is purple and orange. Yeah, it is. Okay. Purple and orange goes here. That's easy enough. There's a red and a black. I don't know where that goes. I got to trace that out. Where does that red and black go? But I'm going to cut these off and cut those off and splice that on there. I'm guessing this red and black is probably just the power to the speed controller. And the brown and yellow, I don't know where that goes. I gotta cut somewhere shrink. So I will speed this up. I mean, I'm sure you guys don't want to sit here and watch me figure out what wires are what. But as I said, for right now, I had a purple and orange coming into the one over here. And then the red and black, but there's no red and black here. So I got to figure out where that goes to the speed controller. Oh, there is a red and black. Oh, that's coming off the speed controller. There we go. We're just trying to duplicate this wiring. So if we have to, I got to remember this is a good drive here, so. Okay, that's the LED motor AP68s. Yep. 12 volt, 1.8 degrees. These are going to work, dudes. They have exactly the same stepper motor with the same degree of step. Same controller. Awesome. This one has a little bit different casting. No big deal. It's all going to work the same. Casting don't have nothing to do with the operation. Alright. It's just tracing out these wires and getting the right ones in the right place. Trying to figure out why there's okay, that header is correct. I got this header, which I'm going to cut off. Because that's going to have to go on. We got to find out where these wires go and find out where they are on here. So what you need to do is you got to have a pin or something to stick in here. We're just eliminating possibilities as we go here. They go to this three-way connector, color to color. Okay. I can't tell you what pins they are. You guys will just have to beep them out. It's not that hard. Do it right on the bottom of your drive to your speed controller. And I don't know what pins they were on the drive that was in the Mac. This will be exciting when it comes time to try this thing. I don't know if I'll get to it today. Or not. Okay, there's 4 wires that come up here that you can't see very well. And there must be an optical switch because there's 4 wires. There's a purple and an orange. And a brown and a blue. Purple and orange and a brown and a blue. Here's the purple and orange together. And the red and the black must be the brown and the blue, I'm guessing. Why did I cut those wires off all at once? I don't know! Bob! What the hell? Let me look at this guy. I need to look at this ELPS drive is what I need to look at. Forget that. Let's see what these have got on there. Okay, there's blue and brown. There's red and black. So the blue and brown have got to go to that end of the connector. Yeah. So the purple and orange go to here. Purple and green. Okay, so that's got to go to this one. Let's get this one done first. Rock and roll and rock and roll. Okay. Gotta find out where the red and black go. I bet you they go to the light bulb. No, there's already a blue and brown coming out of this, though. Oh no, that was your... orange and purple. Orange and purple went there, okay. The red and black. I bet you they go to the LED power. Okay, let's see. Oh, probably goes to the LED. That would be the LED output. So where's the LED on this guy? The LED on this guy is in the case. So that red and black. Just gonna hook this up. That blue and brown has got to be it. Yellow and brown, blue and brown. Just a slight difference in color code. And that's tied together and goes into the sensor. I don't know where the LED power comes from. We're going to have to figure that out on the Commodore. I'll just have to trace it back. And that shouldn't even change. That's coming off from the motherboard. So I don't even need to do anything with that, do I? Do I? We are whittling away, wire by wire, figuring. Well, alrighty, let's tear this baby out. So let's see, what do I have to do? It looks like I can't reach with that. Of course, this is junk. Anybody want some Apple drives? Parts? Alright. Come on out, DOA. There's nothing I can do with you. You are trash. And now we need the new Alps drive here. Activity light? Is there something hanging off in this? There's no extra wires that I can see that aren't hooked up. We've hooked up everything except those red and black wires. So I think that might be just the activity light or something like that, or the power light. But why would it come out and go over there? I don't know. I just don't know, Margo. I'm going to keep these up in the air. I've got to put a couple of screws in this board so she don't dance around like a... Oh, wrong screws. Okay. Let's see if one of these will work. Nope. They work. I only need like two of them. I'm not going to be running this for hours. Okay. The reallocation is done. I don't see any problem with this. All right, guys. We're gonna power down here and go out and try it out there. Guys, we are set up. We will turn everything on to see if I got a monitor. All right. Turn on the Commodore. Let's see what the drive does. It ran for a second and quit. All right. I've got my Commodore disk here. Shove them in. Latch them. And what do? It ran and stopped. And it read something, because I'm getting some gibberish up here. I think this disk might be corrupt. Let's do the disk test. Other than the fast load. All right. I got my chart. Dead test diagnostic. Let's do speed check first. Okay, well, I don't like that. Oh. Look at the alignment. It's running the alignment check on an ALPS drive that I saved from an old Apple IIe floppy. And look at the quality of the read. I'm getting all 100s. It might need a little alignment, but it's not bad. This disc was supposedly a Commodore disc. I'm getting negative 100s on the mid things, but I don't know, baby. Press any key. All right, let's do F1. We're going to take that disc out. Put that disc in. Let's go right for a performance test. Formatting. I didn't even clean the heads. I see the head stepping. If you look really carefully, It'll be coming out into the light here pretty soon. Right here's the head. Here it comes. You can see it coming into the light. It's moving, taking steps. It's formatting. My worry was that maybe the drive would be slightly different to the Apple, and the degrees per rotation of the stepper motor would be wrong, but they're not. It's the same stepper motor too. And these are reading. There you go, guys. I've got to figure out how to print this. How to get this printed with a 3D printer. And now you guys can resurrect all your old 1541s with the Neutronics drives by digging up an an Apple IIe drive or whatever, the 5 1/4 one. Mechanical test okay. Formatted okay. Now it's writing. Now it might not write correctly because I didn't set the jumper on this. There is a jumper in here somewhere that I might need to set for that. So now we're writing all the tracks. We'll speed this up. We're writing the tracks over here. And reading, open the file, close file, reading. You guys owe me big time. I don't know why. I got this idea when I saw Adrian a couple of weeks ago from Adrian's Digital Basement take the Apple IIe drive and put it in a Commodore case. Basically, that's all he did, is he put it in the Commodore case. But then he's the one that got it out and said, oh, it's exactly the same thing as the Alps drive. Passed. It passed the 100% check by dropping an Apple IIe drive into an old 1541 with a Neutronics drive. All I had to do is figure out the correct wiring for these headers, and most of them were kind of self-evident, and apparently I got everything right. Now I had to cut these headers off the old one and swap the wires one at a time to make sure I didn't get confused. But everything's working. I'm thinking this is just the activity light. I'm not sure if it's the power light or the activity light. The power light's over here, so the power LED would be on for that. So I'm friggin' flabbergasted. I didn't do anything to align this drive either. It's perfectly aligned the way it is. Now, that's reading and writing. I'm not sure. Well, we did the alignment test, and the alignment test said it was perfect. Let's do no. Let's just try the alignment check again. I want to see what the alignment does now. It should be almost, these should be almost perfect, because we wrote that disk with this drive. So yeah, they're all going to be 100s and zeros in perfect tracks, because this don't care where it starts and begins. You've got to line it up. If you buy factory discs, they've got to be calibrated to the right one. But it did pretty good with the beat up Commodore test disc that I have. Well, there you go. I'm getting almost all zeros. I got one -5. But that's to be expected. They say don't pay any attention to those mid tracks, so I don't. You try to get them low, try to get them below 100. We'll try the alignment test here in a minute. Well, this guy definitely needs a new power supply, and I ordered some already. So we're going to gut this and put the new power supply in it too. So I'm guessing that's the activity LED right there. And that's got to hook up somehow. I'm not sure exactly where it's going. Perfect. All right, guys, I will be back to you.
I tell you